Discs are not like a hockey puck. They're not solid. Okay? Discs are like this ball. Okay? The outside of the disc is a very tough shell, so to speak, and it's pliable. Inside the disc, there's a fluid. Okay? The outside is called the annulus. Inside is called nucleus pulsum. I'm just going to call it the gel inside the disc. Okay? I want my balls back. Give me. Throw them back. Can't have them. Everyone got a chance? Right. So, and discs are not round like this. They are flattened out. So if we look at L5, put the disc here, and L4. Now, you can imagine this. Vertebra, disc, all the way up, just like we looked at on the models. Okay? Now, we know the discs are not solid. They actually give a little bit. So when I go like this, or when you run or jump off a 2-foot ledge and you land, all your discs have a little bit of give. It's like a shock absorber. It's pretty neat. Okay? Now, when I bend forward and my back rounds like this, if we look at the spine with this model, when I'm bending forward, my back right here is rounded, because a healthy back has a curve this direction. Okay? Here we go. But when I bend forward, look what happens. Things round out. These are called spinous processes. These bumps, you can feel them right up and down your back with your thumb or your finger if you like. They separate. It's just basic physics and mechanics of the back. Okay? But something very key happens when your back rounds out this way. Okay? Let's look at the disc and see what happens. All right. So when you bend forward, like I did to pick up Gumby, and those spinous processes separate, and the discs have to go like this. Okay? And then they go like that. And what it does, it forces the fluid inside the disc this direction right towards the spinal cord and all those nerves that I had on the slide before. I've got a real nice illustration right there. And the arrow on the disc shows which direction the fluid in the disc is forced. Back towards the nervous system. Okay, so when you bend forward, the one on the side there, on the left side, shows exactly what happens. Okay? Now, there's an interesting thing that happens with your back. When you bend forward, like this, with poor body mechanics, to pick up Gumby or whatever the object is, that position of your back right here is no different than if you sit in a chair, a nice soft chair or any other chair, and you slouch forward like this. Your back is rounded. Now, I'm not going to move my back, and I'm just going to go like this. See how that's the same, picking an object up, as sitting with poor posture. So your back, literally, your discs, literally gets stressed when you're sitting with poor posture. Okay? So what happens to that disc? If we sit with poor posture every day, we bend over with poor body mechanics every day, and lift heavy things which make it worse yet, let's find out what happens to the disc. This gives a super demonstration of it. All right. Here we go. We bend forward, pick something up. We bend forward, pick something up, keeping our back bending, and we sit in a nice soft recliner, and things bend like this in our spine, and the fluid wants to get forced out this direction, and the annulus, the shell, actually starts to decay or have weak spots. Not everyone, but certain people will have weak spots in their discs, and what will happen over a number of not weeks or months, but after years of bad habits, this can happen. We bend, and then finally, boom, right there, a herniated disc. That's a really nice model of a herniated disc. Discs bulge, they don't slip. You don't slip a disc, you bulge a disc, and that bulge goes right into tissues, and if it's into a nerve, it becomes very painful. It can be painful without going into the nerve as well. That's the worst case scenario. The even worst case scenario is that actually ruptures and you get that fluid into your system, and we don't even want to go that far. We want to prevent that.